So hopefully I scared you away from using URI search in that previous lecture, but you will run across that once in a while, so it's important you know what it is and how it works. But most of the time you want to stick with request body search, where you're actually sending a JSON request as part of the request body to Elasticsearch. And we've seen a bunch of examples of this already in the course, so let's just talk about it in a little bit more depth and take a closer look. So here's a JSON equivalent of a request body search for that same thing we did in the previous lecture, just looking for movies that contain the search term star in the title. And you can see here the beginning of the URL looks the same. It's the actual host name and port, followed by the index, followed by the type, followed by _search. And I'm sticking pretty on there to get nicely formatted results. By the way, in production, you wouldn't necessarily need the pretty argument. If you're just dealing with the response in a programmatic manner from an app or something, that can just eliminate some overhead that you might not need otherwise. So only use pretty when you're messing around as well. And the request body is where the magic happens for the query itself. So here you can see that we have a more structured definition of the search query. We are defining a query block. And within that query block, we have a match clause. And that match clause contains the actual match operation of matching the title field to the term star. So figuring out how to structure these requests can get a little bit confusing. Often you need to refer back to some examples or the documentation to get it exactly right. But at least when you look at it, it makes sense, and we generally don't have to deal with weird URL encoding because we don't have all these weird cryptic characters to make up URI searches. By the way, you might not have seen before, but GET requests can have a body. Usually when you talk about GET requests on HTTP requests, you're talking about just retrieving a web page from a web server, but you can actually send a body along with a GET request as well. Sometimes that trips people up. It is a legitimate thing to do. Anyway, things you can do within a query, you can have two different things. There are filters, and then there are queries. So queries are usually used for returning data in terms of relevance. So when we're doing something like searching for the search term Trek, you would use a query because you want to get back results in orders of relevance as to how relevant the term Trek was to that given document. However, if you have a binary operation where the answer is basically yes or no, you want to use a filter instead. So filters are much more efficient than queries because not only are they faster, but the results can be cached by Elasticsearch so that if you do another query using the same filter, it can get the results even faster. Let's look at an example of how that might look. So let's do that other second example that we did using a URI search in the previous lecture and see how you would do that using a request body search instead. So here we're again structuring a query, and within that query we have a Boolean query, a bool. That means that you can combine things together. And the equivalent of an AND with a bool query is called must. So by saying must term title Trek, we're saying that this query must contain the term Trek within the title to be a valid result. But we are further going to filter that result by having a range query that contains the year greater than or equal to 2010. So again, the syntax is sometimes something you just have to look up, but this is what it will look like for this particular example. And this syntax does change from version to version even. So this is sort of the new way of doing it in Elasticsearch 5. But it is easy to read. So if you look at it again, you can see we have a query that contains a Boolean expression where you must have Trek in the title, and you also must have the filter past the condition of the year being greater than or equal to 2010. And those sorts of range comparisons must themselves be within a range query. So that's what that would look like. Now there are many different kinds of filters. Range is just one of them. You can also do term filters. So if you need to do filter by some exact value of a term, you can do that with a term filter. It would look like term year 2014, for example, to filter out only things that contain a year that equals 2014. You can also do terms if you want to match anything in a list of values. So a terms filter could say, in this example, anything that has a genre of sci-fi or adventure is what that reads out to be. We already looked at a range query in the previous slide. If you want to just do a greater than or less than, or greater than or less than or equal sort of operation, that would be a range filter. There's also an exists filter where you can just test if a given field exists at all within a given document. Again, the schema is only loosely enforced, so you can in fact have documents that are missing fields entirely. And if you want to just test if it exists or not, the exists filter is what you want. And the opposite of exists is missing. If you only want to find documents where a given field does not exist, you could use a missing filter. And finally, there is a bool filter as well. And we looked at a must example. That's basically the equivalent of and. There is also a must not, which is the equivalent of the Boolean operation not. And there's also a should, which is the Boolean equivalent of or. So you can do complex Boolean filters where you can have conditions that must be combined, with and relationships or relationships or not relationships and whatever you can imagine using a bool filter. Queries, there are different kinds of queries as well. So just like there's different types of filters, there's different types of queries. Match underscore all is the default, but it just returns everything. So if you don't specify any query at all, you get back everything. And that's the equivalent of saying match underscore all. So typically you wouldn't actually see that in use because it's sort of implicit if you have no query whatsoever. Match is the more common operation where you're doing some sort of a relevant search for a given search term or terms. And you can also do multi-match, which allows you to query multiple fields at the same time. So that's kind of a handy little shortcut there. There's also a bool query, which is the same thing as a bool filter. You can have must and should and must not operations in there, but the difference is that instead of filtering out results that don't meet that Boolean condition, it actually scores the results by relevance. Now, a reminder on syntax. Queries are wrapped in a query block. Filters are wrapped in a filter block. And you can combine filters inside queries, and you can combine queries inside of filters to do more complex things. And that's exactly what we're doing in this second example here. Again, we are wrapping a filter inside of a Boolean query here to actually achieve the search query of, I want things that have truck in the title and have a year greater than 2010. Greater than or equal to 2010 more precisely. So you can do some pretty complex stuff if you combine things in creative ways. Let's see how it works. Let's get our hands dirty with those full body requests that we saw in the slides and just make sure that they work. We're going to just do the same things that we did in the URI search examples, but this time doing it the quote-unquote right way using JSON requests as part of the request body. So let's start off with that first query of just matching all movies that have star in the title. That would look like this, curl-xget 127.0.0.1:9200/movies/movie/_search $pretty just to get nicely formatted results -d quote, and now we will start typing in the request body. Start with a curly bracket, and we'll start with query :curly bracket match :curly bracket. Again, you don't have to deal with tabs if you don't want to, but I'm doing it here just to make the results more readable. That match query will contain a title that matches the term star. And now we just need to close off all those curly brackets. And end quote. So you can see that we didn't have to deal with any sort of weird URI encoding here, and the results are very easy to understand if you look at it. So again, we're just doing a query where the query matches the title field containing the search term star. Pretty easy to understand. And sure enough, we get back meaningful results. Star Trek Beyond, Star Wars, both contain the word star in the title. Cool. Let's do that more complex example as well, where we're going to look for movies that contain Trek in the title and were released in the year 2010 or later. curl-xget 127.0.200/movies/movie/_search $pretty -d single quote, and the request body would look like this, curly bracket. Again, we start with a query block, and this time we're going to have a Boolean condition within that query. And this includes a must clause within the Boolean condition. And we are going to do a term query where the title must include the search term Trek. And furthermore, we must pass the following filter, which is a range filter, where we are testing that the year field is greater than or equal to the value 2010. Close off those brackets. And we're good. So to break this down again, we are doing a query that contains a Boolean query, where we have a must condition with a term query where the title field must contain the term Trek, combined with a filter that is a range filter on the year being greater than or equal to 2010. And let's make sure it works. Sure enough, we got back Star Trek Beyond, the only movie in our database that was released after the year 2010 that contains Trek in the title. So there you have it. So again, it's a little bit more typing, a little bit more dealing with tabs and structure, but it's worth it because you don't have to deal with weird escape codes. You can actually see what things mean pretty easily. It's a lot easier to debug and understand what's going on. So JSON search, the right way to do things.